Hey guys, so here's the thing. You're getting a real deal today. You're getting a live me in front of the smartboard, so we'll have to see how this works out. I'm not sure how well you can see it or not. So if you need to, try and make it full screen and see if you can actually read what's going on over here. All right, so I'm going to try and keep my head in here a little bit for you, but here's what you need to know. Okay, we're going to be looking at genetics and probability. So when we look at genetics and probability, right, probability is really about the likelihood that an event is going to occur. And so how do we figure that out? Well, if you think about it, when you flip a coin, you flip the coin and you either get heads or you get tails. So there's one of two possibilities. Just like having a baby. There's one of two chances it's going to be a boy or a girl, right? So it's 50-50. So, I just said 50-50. I really wanted a girl for my first child. And you know what? I had a 50% chance. That's another way of saying it. But I didn't. I ended up with a boy. Went the other way for me. No big deal. So you just looked at a lab that dealt with determining probability. And you probably found that that probability changed with every offspring, with every family. Just because a family has one boy doesn't mean that their next child will be a girl. The probability is the likelihood that that event is going to occur, and that means that that likelihood starts over every single time. Okay, so how do we figure that out in genetics? What does that exactly mean for us? A Punnett square is the method used to determine the probability or the likelihood that an event, in this case, a trait, is going to be passed on to the offspring from the parents. So how do we determine that? Well, there are these basic steps, and what I want you to do is I want you to focus and I want you to write down these 5 basic steps. Maybe you've worked with Punnett squares before, maybe you haven't, okay? So take a moment right now, go through, record these 5 steps, and then we're going to go on. So pause right now. Actually, as soon as I zoom in for you here, I'm going to bring it a little bit closer. Sorry, you got the finger there. Can you see it? Not quite. How about now? Can you see it good there? Go ahead and pause right now. Awesome. Let's get set back up here. So what I wanted to do for you is I wanted to demonstrate for you how to work through a Punnett square. So let's say we were working with Mendel's pea plants. I have to set up my Punnett square, which is very, very much like making that tic-tac-toe board, right? Following my rules, I have to set up my parents. So the parents that I'm going to cross, let's say I am using capital T for tall, which I am not today, and a lowercase t for short. Okay? Hopefully you can kind of see what I did there at the top of the screen. Now, let's say I was going to cross a homozygous dominant parent with a heterozygous tall parent. So I take one parent and put them down the side. My top box is my times box, if you will, if you want to think about it like a multiplication table. And then I put my second parent across the top. It really doesn't matter. It's just like saying 2 times 2 is 4 or 2 times 2 is 4. It really wouldn't matter which way you put it. So as I do this, now what I'm going to do is I'm going to actually have both of those alleles combine, just like the egg and the sperm combining would create that allelic combination or that genotype in an individual. So now as I follow this one down and bring this one over, that's what I get. Then I do the exact same thing here. I bring this one down, bring this one over, and then I bring this one down and bring this one over. Notice how I wrote the dominant trait first, okay? Dominant trait always goes first. So now I've got my 4 possibilities for my offspring. As we look at these, we have to look at 2 different things. We have to look at genotype. So first, what are my possible genotypes in my offspring? Well, hopefully you're recognizing that there is homozygous dominant, and how many of those do I have? 2 out of 4, or 50%, right? The other genotype I have is heterozygous. And so heterozygous, I've got 2 out of 4, or again, 50%. Now the thing with genetics is we always try and write things then as a ratio. And so as I'm writing this as a ratio, I want you to take a look. Sorry, I'm going to move this just a little bit so that way you can see it a little bit better. So as we write this as a ratio, and I know that I keep going dark, and now I'm in the light, now I'm in the dark, now I'm in the light, now I'm being silly. Okay, so I have to write this as a ratio. So how do I write my genotype ratio if I've got half homozygous dominant and half heterozygous? Well, I can simplify, and I can write it as capital T, and there is 1 out of 2 of those to 1 out of 2 heterozygous. Or I can write 1 capital T to 1 heterozygous. The reason I like to do it this way is it's easier to read, okay? It's a lot easier to read that. Now, what happens now when I need to write the phenotypes? What is the phenotypes again? Hopefully you said physical feature. So when I'm looking at the phenotype, this genotype right here, capital T, what is that offspring going to look like? Hopefully you said that capital T is tall. Well, what is the heterozygous form? Hopefully you said that one was tall as well. So if this one's tall and this one's tall, what is my results? I get 100% tall offspring. So that's going to be my phenotype ratio. It's just going to be written as 1 tall, because they're all tall for this particular example. Should we try some other examples? Whoop, too far. My bad. Mrs. Learned, good gravy. Okay. Nope, that's even too far yet. Let's get rid of this one. Let's completely get... Oh, honestly, I'm not even touching anything. Wow, we jumped way back, way down. Whew! Sorry about that, kids. Okay. Of course, it never works for me. It works for other people. And then I go to try it. Let's try it again. 1 loop, circle. Nope, doesn't work. Loop, circle. Nope, doesn't work. All right, sorry you got to sit and wait through this, but it's just like a live lecture right now. Okay. Here's what we're going to do. This time, let's try capital T, lowercase t, heterozygous parent. Now let's do this. Let's do homozygous recessive. I set up my Punnett square. Do this one on a separate sheet of paper, see if you can get it. 1 parent, 2 parents, second parent, right? I bring my alleles down and over. Always write my dominant allele first. Bring the the lowercase t and the lowercase t down and over, here, and here. Now, things are changing on me, right? My genotype ratio, I have 1 heterozygous to 1 homozygous recessive. My phenotype ratio, is it the same as it was before, or is it different? Hopefully you're seeing that I've got 1 tall to 1 short. You might be saying, but Mrs. Learned, there were 2. There's 2 short, there's 2 tall. It's okay, I'm just simplifying. That's all I'm doing. So instead of saying 2 to 2, 1 to 1. means that they're equal in ratio, equal in probability, equal in determining the sex of the baby. Boy versus girl, it's the same thing. So we're going to do some practice problems and see if we can't do them correctly. And if you've got problems, make sure that you come up and ask.